you're given a binary representation of a number as a string. So on the left side of the arrow we can see that we have a binary number, and then we'll convert this to a decimal number. So I know you guys can easily solve this with loops, but once you learn recursion, you will find that doing this with recursion is very much easier. So at first, let's try to solve this with loops. So if we want to convert this number into a decimal number, let's first do this character by character. So if we just want to convert this first character, which is just 1, so its binary equivalent will be 1, but then we will determine the decimal equivalent of the first 2 characters, which looks like 10 here, but this is actually 2 in binary. If we convert the first 2 characters to decimal, this will be 2. Then we will convert the first 3 characters. So 101 looks like 101, but it is actually 5 in decimal. So we how do we get the binary representation of the first 2 numbers from just the first number? So the first number is actually 1, and if we want to convert these first 2 characters, which is 2, so when we get a 0, we actually double the number. So at first it was 1, then we double the number and we got 2, and then if we get a 1, we double the number and then add 1. So 2 double is 4, then plus 1 is 5, and then 101 is 5, then we got another 1. So double 5, which is 10, plus 1 equals to 11. So 1011, these 4 characters mean 11 in decimal. So we do this with a for loop. So in each iteration of the for loop, we just check one character of the string, and then we decide whether to double it or to double and then add 1. So let's see the code now. So in this function we're passing a string, then we are declaring a number which is our desired decimal number. So in the iterative loop, we are always checking for a character. So if the character is 0, then we just double this number, and else if the character is 1, then we double and then add 1. Then finally, when the loop finishes, we return this number. But we can, as I have already said, that we can always convert a loop solution to a recursive solution. Now let's see how we can convert this iterative solution to a recursive solution. So first, notice that there are a few variables that enter this loop and they get changed and then gets out. So we come to this loop with a string s and then integer number which is 0, and then int I equals to 0. So after each iteration of this loop, 2 things change. Number changes, num gets double or double plus 1, or I gets incremented, which is I plus plus, but s doesn't actually change. So in this recursive BDT, we will have these 3 variables as well, but s will not change, but I and num will change. So actually recursive function is just the interior of a recursive function is just the interior of the loop. So if the character at I is 0, we have checked this here as well, so we double the num or double plus 1. So from here we go to the next recursive call, which is actually the next iteration of a loop. So after the completion of these steps, which were completed here as well, then in the iterative solution we went to the next iteration of the loop, and now we go to the next recursive function call. So let's return recursion s I plus 1 num. As I have said, num has changed because num were edited here, right? Num was edited here, and I has changed as well because we have checked for I, but in the next recursive call we're going to check for character I plus 1. So notice that s didn't change here, and we have another additional line. If this if condition, we have said that this condition is actually the base case, and the base case is actually the uh, the condition checker of a for loop. So when does this for loop end? When I get so large that it becomes s dot length. So since we are incrementing I here as well, at some point I will become equal to the length of this string. So then it will return num. So we have seen how to convert an iterative solution to a recursive solution. So now let's simulate this both of these approaches. Um, so here is our number. Uh, this is our string, which is the binary representation, and this is our decimal number. So we haven't started this for loop yet. We just declared this number. So the number is 0 yet. So 0 so far. So if we start this for loop, we are starting for the first character I equals to 0. So we are checking for character at 0. So we check the first character, which is 1, and then since we go to the else case, if case isn't true because the character is not 0, so we go to the else case, and the num gets twice plus 1, which is 1. So num is 1, then we get character is 0, so we double this number, then we go to the third character, which is 1, so this will go to the else case, so the number gets doubled plus 1, so which is 5. Once again double plus 1, which is 11, then double 22, double plus 1 45, double plus 1 91. So now let's simulate the recursive approach. So we have noticed that we are calling this recursive function with 3 variables: the string, the position, the number, the index of character we are scanning, and then the number. So let's call this function with a small same string, which is this. Actually I'm not writing the I here because for space issues. So instead what I'm doing is I'm just shrinking the string, because look here, when I equals to 0 we scan the first character, which is 1. So instead of changing I in the simulation, I'm just shrinking the string by character 1. Notice that I have omitted the 1 here. So in the next iteration I'm going to omit this 0 because this 0 is already scanned. So I'm just writing the decimal, the binary representation and the decimal representation side by side so that it is easier for you to understand. So each time we are scanning one character, we are shrinking this number, and then if we get since this character was 1, we will multiply 2 with we'll double 2 and then add 1, so this will become 5. And notice that this was the first character in this case, so when we scan this 0 we just doubled 1, then we scan this 1 and double 2 and then added 1, and then since we got another 1 we'll double 5 and then another 1, so this will become 11. So since this is 0, this 11 will get doubled, which is 22. and this is 1, the first character is 1, so we will double this and add 1, which is 45, and then we will get 91. So at this stage I will increase and will be equal to the length of the string, and then we will return the number which we have so far, which is now 91. So this will become 91. Okay, thank you.